Let us do in this video this example where we need to sketch the graph of a single function f such that these two conditions hold. The function is continuous everywhere except for x equal 1 and 3. And then f is differentiable everywhere except at 1, 3, and 5. So let's get to it. Let's draw the axis. All right. And then first, let's put 1 and 3 here. So this is 1. This will be 2, 3. These are the discontinuities, right? And then we have another special number. So this is 4, and then this will be 5. 1, 3, and 5. Okay. I do this just to have a reference, a referential. Okay. So now we need a function that is continuous everywhere except at 1 and 3, and then differentiable except at 1, 3, and 5. So let's keep it simple. So discontinuous, let's do some jump discontinuity, for example. Let's use a different color maybe. So it can be something constant up to 1, okay? And then continue somewhere else. Let's say it continues from, so this could be 1 and this could be -1. Well, let's say -3/2, okay? It could continue like this. And then we need continuous everywhere else. So let's do, let's say it goes from here, continuous all the way. It could be 2. And then it can go, it can just continue, right? But careful here, we need to make sure it's, let's see if we have done everything we need. So it continues everywhere. So far so good, except 1 and 3. That's correct. Now, differentiable everywhere except 1, 3, and 5. So remember, a function being differentiable is better than being continuous. So if a function is not continuous, it's not differentiable for sure. We saw this in a previous video. So points x1 and 3 and x1, x equals 1 and 3, those two are covered because the function is not even continuous, so it cannot be differentiable. Okay, so 1 and 3, those two are okay. Now 5, we need to make sure the function is clearly discontinuous at 5. Okay, so for discontinuity, for differentiability, there are 3 possibilities. Either we have a discontinuity, or we have a corner, or we have an infinite slope, okay? Because the function has to be continuous, probably the best solution here would be to do a corner. So instead of what I drew, let's just continue with a line down, okay? And emphasize here that there is a corner there. So there is a change in the slope, okay? It goes from constant slope to a negative slope. On the left, the slope is 0, okay? And then on the right, it's negative. So it changes abruptly. So it's not differentiable because the limit from both sides is not the same.